Welcome everyone to today's Observability Clinic, a very pressing topic, vulnerability detection and automated risk assessment. This is part of my Observability Clinic series. You can find this video on YouTube as well as on Dynatrace University. And if you are on University, you can also find the slides. I am not an expert in security, but I invited somebody that knows a lot about it because he's also putting the latest AppSec capabilities into the product. Therefore, I want to welcome Andy Berger. Servus.
Servus, Andy.
Hi. Andreas, I want to give you the stage right away because I know you have a lot of things to show us, especially around the latest improvements in AppSec. I know you are a senior principal product architect at Dynatrace, been here for a while, but I want to shut up now. Just encourage everyone. If you have questions, put it into Q&A. And if you're watching this offline, then I'm pretty sure with our names, you can find us either online somewhere or in the community.dynatrace.com. But with this, I want to pass it over to you, Andy. Enlighten us. And if there's questions that are coming in, I may interrupt you. Maybe you give me a chance as well. If you have a pause, then I will see which questions are coming in because we want to get as many of them answered as well.
Sure, let's go. So it's also my first time here, so he finally accepted me. I apparently did something good there, so let's kick it off. So what are we going to talk about today? Obviously security. I want to give you like a quick outline of what you're going to learn today. So I want to talk about how impact assessment of vulnerability or security incidents in general can be easier than it is today. And that's hinting at how an asset inventory as provided by Dynatrace in a way, combined with security data, makes this kind of process of figuring out what impacts you much easier than it is today. And you'll see more about that later. Then I also want to, I have a big emphasis on context. You will hear that many times today. So I want to explain why I feel that for security investigations, context really matters. And you will see some several examples there. And then I'll talk about the latest addition to the Dynatrace product, which is a feature that is helping to detect and block attacks. Also very much in the context of, well, the other context, right? It's doing that separated from everything else makes no sense to me, and I'll explain why. So without further ado, I just want to show you like 4 or 5, I don't remember exactly, slides, and then jump directly into a product demo and walk through the actual details there. But first, I want everybody to understand what we are talking about here. So Dynatrace application security is a relatively new area in the Dynatrace product. And it's not just about a particular feature. It's like a whole set of things. It's a strategic investment area for Dynatrace. And what I'm showing you today is the first piece on the journey that will take much longer than that. So that's an area where Dynatrace is currently massively investing in. And I want to show you also part of the vision and where we want to take that. And this is the vision part, right? Application security is hard. And why is it hard? Because when we talk to our internal teams, and that's just a snapshot from our own internal monitoring, there's just so much going on, right? That's an actual snapshot from our own development environments. And we have more than 1,400 hosts monitored there and about 11,000 processes. And that means with our roughly 1,400 developers worldwide, there's just a hell lot of dynamics going on. And our security team is struggling to keep up with everything that's going on there. And putting all these controls in place for such a heavily changing dynamic environment is simply very hard. So when talking to them, we realized that there is like 3 different things that keep them busy across the board, right? And these 3 things are, they have lots of tools, of course, in place. And for some of these tools, they also have security findings. And that means there's a ticket somewhere in Jira or in ServiceNow or wherever that allows you to track that problem. Your only task is then to make sure the development teams are actually working on these things and pushing the fixes forward. But that's actually the best situation, right? The other thing they have is they have findings in a log file somewhere, reported in an event somewhere that is not contextualized. It doesn't have a ticket assigned to it. It's not trackable. And therefore, it's not tangible for the security team and also not for the development team. So it's somewhat a bit of a waste, right? This finding is there, but nobody's really doing anything with it. And the third part, there's of course a hell lot of unknown stuff. And there the biggest problem is coverage, right? So you might have tools, but maybe this one important project was not set up to be covered by your security tools. And that's a problem as well, because you cannot know what you cannot know, right? So summing up all these three areas, we feel when talking about security, like the basic pillars are, we need to establish simple coverage everywhere where it's needed without lots of configuration effort. We need to have operationalization. That means we need to be able to do something with the findings, create a ticket, enrich it with context. And then also we, of course, need to make sure that the findings are accurate and actionable. That means assuming that there is not a security specialist dealing with this issue, still the findings should have all the information that is required to make progress. So those are the basic three elements of that. And I'm just looking at you, Andy, if there is any like question already or any reflection on that.
I think for me, the reason why I invited you, it's like you said in the beginning, jokingly, you must have done finally something good to get on this. But seriously, we were sitting in a room a couple of weeks ago with clients, and you actually showed this. And I think this was for me a big eye opener, because it actually shows that there's so much unknown potential here of security vulnerabilities. And this is where we're completely flying blind. And I also like the operational side, operationalization. Now that I get it out, takes a while. I think these are very important things. And I think a lot of us are, at least from my perspective, new to security, but security is the job of every one of us. And I think we should be more aware of what's actually going on. And this is why I like this. Otherwise, there's no questions so far from the audience, but thanks for giving me the chance to remind everyone, if you are on the call, please use the Q&A feature and then have your questions raised there, and I will make sure to bring it to the attention of Andreas.
Thanks, Andy. So moving on here and reflecting or responding to what you said with making it everyone's problem, basically to deal with security. I just want to hint also back to the cloud native security white paper, because several elements there underline also this thinking, right? So there is this quote here that security requires a paradigm shift. It needs to move closer to dynamic workflows. That's related to what I was hinting at. There is just so much complexity out there. Also there is constant flux, right? So everything's changing all the time, and we need to have easy coverage out there in order to make sure that even in this constant flux, everything is is covered constantly without the deterioration in coverage quality, right? And then third element there is guidance that we should stop like doing like scans once a month or once a week or whatever. We need to do that continuously, and that's obvious, right? The environment is changing basically every minute. So why should we sit back and just do a security scan or only once a week? That's simply not enough. And my most favorite one, and this is not the first time I'm hinting at context, is what the CNCF also found is that for really being able to speak about the actual risk that you're exposed to, you need additional information. It's not enough to say there is an alert and you have a vulnerability. It is important to understand the context of a vulnerability, to understand how to prioritize them, right? It makes a difference whether a vulnerability is found in a dev environment that's shielded from the world, or whether it's on your most important production system. So using context for prioritization is absolutely a thing. So what are we going to do? And that's really like the big vision for Dynatrace AppSec. We are convinced that observability gives you the full picture of your environment, and that's in contrast to most of the other security tools out there, because we don't want to deal with security in this kind of isolated way, just looking at libraries or just looking at the security of the container orchestrator like Kubernetes, but we want to do all of that in combination, because in the end, it doesn't really matter which element of your stack is vulnerable to something, when the outcome can be that I can execute code on your machine, right? For somebody who is protecting the system, it's really irrelevant whether it's the library or the Kubernetes system. So what we want to do with Kubernetes, with Dynatrace, is we want to cover the full stack, the full stack of your environment. And we do that already now with observability, right? We cover not only the running processes down to code level, but we also know where your application is running on a Linux host, using which container runtime, using which Kubernetes system. And now with security, we want to combine that, right? We want to say we have visibility in the entire environment, and that allows us to also tell you what is your actual exposure relative to your assets, relative to your vulnerabilities in your environment. And that's then complemented with what I called here dynamic analysis. Because so far it is the environment as it is, and it's just an analysis of your environment. But when you look at now, at also how it's being used, then we can throw traces in the mix. We can throw logs in the mix, and which, as you can see later, we can also show attack information in there. And all that combined together allows us to derive a better understanding where really the risk potential is. We are not relying on just one element of the stack there and just one source of information, but we're combining all of that together to give you like the big picture of what's really going on. Okay, so all in one platform, we want to work on the three major things here. And before I now jump over to the demo, I'll ask one more time for reflections or any questions that might have arisen.
Yeah, a quick reflection, because I was lucky last week. I was at DevOps Days Amsterdam, and I was speaking there on DevSecOps and basically raising similar questions that what you said, right? It's the full stack that is important. And the interesting thing is, it was not just us talking. Half of the talks on day one, at least at DevOps Days Amsterdam, were somehow focused on security and having an holistic view on it to really solve the problem. And because it was a DevOps conference, right, the focus was really, how can we not just look at security problems in production, but how can we kind of embed security as part of the DevOps lifecycle of your applications. And now as observability is making its way into the lifecycle, security that is based on observability is just, I think, easier to come by because, right, observability is the driving factor of detecting all of these vulnerabilities. And as you said, I mean, I know you'll show us in the demo how we combine the full stack information, the distributed tracing, and then being able to potentially really see, is there a vulnerability that is more important than another vulnerability? And I think this is the key thing, right? Because otherwise you're drowning in alerts, and you want to make sure that you're not drowning in alerts, but you focus on the things that are most important. This is where observability comes in. That's kind of my reflection so far. And I think the first questions are coming in, and maybe I'll give you one question quickly so that people see that we really mean this serious. Does the security solution work on Service Fabric and Windows Hyper-V containers, or just in Kubernetes and Linux containers?
No, it works conceptually, it works everywhere, but the difference is just what we support. So currently there is no specific support for Hyper-V, for examples, but basically what I'm showing here is the vision of where we want to take that. And now what you also will see at the end, we are basically filling the elements of the stack now by adding more and more support for different technologies. So when I talk about Kubernetes, it's just because it's so popular, but you can deploy also on a standard, I don't know, non-container infrastructure, and basically get the same. You will, I guess, some of that you will see in the demo as well.
Yeah. And I think also the other question that just came in from a question perspective, you will show in the demo. It is, how does AppSec prioritize vulnerabilities, right? What makes one vulnerability more critical than another one with the given context? And the second one, maybe you can also touch and show it in the demo. AppSec can be turned on easily when one agent is deployed, but does AppSec need to be activated on each host unit? Like kind of like how can you control, I guess, where AppSec is actually active in a Dynatrace deployment?
So quick reflection on that. I'm not sure if I will have time to go to the settings, but there is ways to control which specific security feature you want to enable on which specific host. So you can either roll it out really broadly or control the rollout or the deployment to just a small subset of your infrastructure. And regarding the other question, I mean, this whole impact assessment, risk assessment, that's actually core of the demo that I'll show in a second. So maybe it's time now to switch over.
Exactly.
And you should now see my product screen.
Yep.
And I wanted to start from something that people might know, that's Smartscape, right? So for those of you who don't know, I'm showing you that here because it's going to be very important later to understand why Dynatrace is able to do what we're doing. Just to give you an example here, you see an overview of my environment, how the services are auto-detected by Dynatrace, and also we understand how the services connect to each other, right? So here is a Tomcat service, and it's talking to a database. And this piece of information is going to be important quite soon. So now I switch over to here, right? Like as a starting point, I want to show you what we call the security overview. In my environment here, I currently see that I cover 100% of a total of 3 hosts, right? So it's basically related to the question. In this case, it's enabled everywhere. And we found one critical vulnerability, but we found a lot of others, right? There is 113 medium, for example. And if you scroll down here, you would also see what are the most affected applications in your environment. So you see that there is one that has 1 critical, but 40 total. So that's like the entrance view, right? So this is allowing you to get a feel for how are you doing. But of course, from here, you can drill down. Now, let me click on critical here, which brings me to an overview of all critical and open vulnerabilities currently in my environment. And I just want to like pause here for a second. This is a live view, right? So if that changes the next second, this view gets updated here. So, and that's really important, right? Because there is nothing you need to do. There is no scan. I don't even like this word of scan, this word scan for what we're doing, because it's a continuous evaluation of your entire system that's always up to date. So there is no risk that the scan just happened, the next one is happening in the next 2 weeks, right? So that's the current situation in my environment. And what do I see here? I see 1 critical vulnerability that's detected. So that's Log4Shell, right? You probably know that. That's Log4j. It's not surprising. Obviously, we also included that in the demo. I just realized one thing real quick. Hold on. Yeah. Okay. So moving on here. Now, what you can see in this on the screen here is that here's a score of 9.9, right? And that obviously that's a very critical vulnerability. 10 is the maximum, but you can also see details there, right? I'm just hinting at a few here. So there's public exposure. There is sensitive data is not enabled. And then there's vulnerable functions. And then there is public exploit. So what this is hinting at is we are doing risk assessment as we find these vulnerabilities. And we are continuously updating this, right? So this is changing as we speak, and it's always representing your current situation. And what's also important here is that's not an alert in a sense that it's just a one-time thing. It's something we track since quite a while now. So we first detected this vulnerability in this demo environment 165 days ago, and we've been tracking it ever since. So that's a living document or a living report that we always keep up to date in order to follow all changes in the system, responding to this high dynamics and this kind of, the CNCF quotes I had up a few seconds ago. So now, of course, we do not mandate that you follow our recommendation and say, this is the most important thing here, right? So you could also say, I don't care. In my environment, the most important host has insecure in the name, right? So let's show me all vulnerabilities that relate to this host. And because I cannot fix 51 vulnerabilities today, I'm only interested in the ones that have public internet exposure, and then down to 11. And I just want to quickly hint at all the possibilities here. You have to slice and dice the data because we acknowledge that typically there is more vulnerabilities than you can fix today. And also the priorities change from user to user, from environment to environment. So you have all the options there to say, what matters to me today is this and that, and I want to start here. And by that, we want to help you to drill down to the stuff that really matters in your environment. Now, without going further into that, and now I clicked, I just want to show you what happens if I click on this Log4Shell vulnerability here. And I just want to highlight a few things here. When you click on this Log4Shell vulnerability, you see at the very first thing, and I just want to underline that it exists currently in your environment. And that's already a lot of information, right? You know that there is at least one process in your environment that is loading a vulnerable version of Log4Shell right now. And that was quite an epiphany for many environments where we turned it on, because typically you thought you had it fixed. Maybe you overlooked that one process that was outdated that nobody cared for. This is allowing you to say it's still there, right? And that's really crucial. And then let's go quickly through what you see here. So you see public internet exposure. How we do that is, now I'm linking back to what I said at the beginning. You saw Smartscape, right? So we know how things are connected to each other, but we also understand by means of our topology analysis and our traces that we see coming in, we understand what is reached how from the outside. So we can understand that something is exposed versus it's not exposed. Then very much related to that is sensitive data assets. We know if there is a database connection to something, right? If there is a MySQL database that is reachable from a vulnerable process, then this would show up here. In this case, it's off. Then let's jump over here, because that's I want to pick the vulnerable functions at the end. The exploits, right? So for those of you who don't know what an exploit is, it's basically a vulnerable, it's a piece of code that allows you to exploit a vulnerability. So you download that from somewhere, there's public internet sites, you get it on your machine, you just give it a target and it will run an exploit that was not written by you, but some expert who knows how to do that. And the availability of this expert obviously lowers the effort that is required for you to exploit that. And of course, conversely, it increases the risk for you to be exploited, because somebody will do that because it's so easy. Then there is currently 2 process groups affected, and obviously the component is Log4j. Now jumping over to here, and this is a key element of what we're doing. Imagine that we are not doing only library analysis, right? As I tried to explain, we are analyzing the full context where the vulnerable library is deployed into processes of which at least one has public internet exposure. But we do that also in like the other direction, if you want. We go deeper. It's not only topology, but we also go down to code level. And we understand which particular function inside of Log4j is the one that contains the vulnerability, right? So if you just use Log4j, but you're not using the actual function that is vulnerable, then currently you're not really safer, but you know that the code is currently not executed. So you should probably focus on the ones first that are running the code actively. So again, it's a mechanism to prioritize and to see where to engage first. Now, I talked a lot about context, right? So what we try to do below here, after like hopefully convincing you that this high-level information is interesting, we want to acknowledge that not everybody is a security expert, and not everybody would understand immediately what to do. And that's why we're partnering here with Snyk, who have one of the best vulnerability databases out there, and who provide you with human readable explanations of what's going on really there and how to fix that. And on top of that, we link that with all kind of other metadata, because we want the developers who see this kind of report can engage as soon as possible without waiting for somebody explaining to them what that really means and what they should do. So we try to provide all kind of context. So let's say you're a guy investigating this issue. So you could go here and say, I'm interested in the actual CVE. Then you would see the actual vulnerability report. And here, for example, is one of the exploits that was published by somebody out there in the internet to exploit the Log4Shell vulnerability. So if you're now in the process of fixing that, what many people, also we did, was they tried to exploit oneself and see whether it works, and then they deployed a countermeasure and then see whether the exploit still works or not. So that's one way to see how we link together information in order to enable people to act independently, or as independently as possible. So Andy, any questions so far? Anything I could answer in more detail?
There's a lot of questions that came in, and I tried to answer. I mean, some you already answered in in your demo, I think the first thing was around kind of like a misunderstanding or not knowing what about the initial score from a NIST database or from Snook. We're not taking this into account at all, but I think you showed this is kind of the base score that we take, and then we're looking at the data that we have, the data in context, and then change the rating based on what we actually see, right?
Yes, exactly. Maybe a quick comment there. So we are using the CVSS score as a base. And then we are applying the contextual knowledge we have. And in this case, we're reducing it just by 0.1. And that's not something, so we specifically tried not to come up with a proprietary solution that nobody understands. So this is following the actual CVSS spec, which has means to take into account environmental context. And this is what we do here, right? So we basically say CVSS as a base is always risk averse, right? It's always assuming the worst, because CVSS doesn't know where a certain vulnerability appears. So they always need to assume that it's in the worst possible situation. But by contextualizing this information, we can help to prioritize. And that doesn't mean you shouldn't care, right? That just means you should care a tiny bit less than for a 10.0 vulnerability. That's even a bit more important, because it's a 10.0, but also takes into account the environment and shows you that in your environment, it's still a 10.0, right? So that's really the magic here. Andy, any further questions?
Yeah, there was just some questions on how does this all get activated, and I explained this is all done through the one agent. So the only thing you really need to do is install the Dynatrace one agent. It's the same agent that does our full stack observability, and on top of that, now through a license, if you purchase the AppSec license, the agent will then additionally provide the information about the security vulnerabilities, or Dynatrace will then enable the security vulnerability capability, right? But it's the same agent. There's nothing else you need to install. And the last question that just came in is, do we need to install the agent on a machine level, or would this also work on other levels? And here again, we have different ways to monitor your systems. Machine level is the best, because then you get to see everything from that machine upwards. We also have Kubernetes operators. You can also do just in container injection. We also have on agents for serverless functions. So we have different ways of injecting, either full stack from host all the way up, or you can also do what we refer to as application only. And Andreas, correct me if I'm wrong, but even for application only, we would be able to do all of the security detection, because it's part of the stuff we see from within that process that we monitor.
Exactly. Absolutely right. So maybe going on here to show you a few more of the highlights. So obviously you see here what is currently affected, right? But you also see something I think way more useful still. You see here, there is this vulnerable function, which has a specific name. GNDI lookup might sound familiar to many of you in context of Log4Shell. And you see, we have currently one process group or application, if you wish, that is using this function. And there's another one who's not. So let me click on that one here. So you see here that I have an application that is called Insecure Bank, which already hints at the fact that it's not very secure. And we see it's using this particular function that is in use. It's using a vulnerable Log4Shell version with 2.14.1. Well, and it's there, right? So it's running. And I mean, at this point, you should run, right? So this is the stuff you would need to know. And I just want to underline that usually it would take me like 10 seconds to click through here to understand that I got a problem that needs urgent care, right? So this is, at this point, the development team would need to be informed. But it gets cooler, right? It's you could still argue it will take us a while to take this down. And let me at this point, basically imagine I put on a hoodie and dark sunglasses now, and I'm now changing to attacker mode, right? So I have here this Insecure Bank application. And as an attacker, I can do nasty stuff here. So I could do an SQL injection attempt, a very simple one here, right? So there's just a very basic SQL injection, and if I do that without entering a password, I'm now logged in as Doug, right? And now I could also do that, right? So that's for those of let's pick the other one that's even nicer. this string here is like the prototype example of a log4shell attack, right? It has this JNDI request in there, and as you can see already, it's trying to install a backdoor. And just to prove to you that there is no backdoor yet, right? So there is nothing running here as much. I can hit reload as much as I want. So let's do that, right? I sign in here, and what happens in the background, of course, is something that happened quite often in the course of log4shell. There was a logger. That logger tried to log the username. The username, unfortunately, was the attack pattern. It writes here invalid username, which is correct, but in the background, unfortunately, the backdoor got installed. And the way we did that here for the sake of the demo is it's installed the backdoor in the same process by loading a class file from a remote location. So what I can do here is now quite obviously everything, right? I can do everything that requires permissions of that process, because I'm running inside of the process. And also I have really nice opportunities to query also the SQL database that is somewhere around here, because it is well, it is possible, right? So I can do whatever I want. And now, as an attacker, I'm done. I hide my traces, and the backdoor is gone, and that's it. And unfortunately, for many cases of log4shell, logging was not really a good option to figure out what was going on there, because it was an attack on the logging framework. So logs were often somewhat limited there. So let's look at what happened in the background. So I can click here now on this very new element here in Dynatrace, and as soon as the screen finished loading, I can see here that we see two attacks, right? So there is an SQL injection attempt, and I'll just show you. I mean, it's following the same guidance as before, right? We see here it was exploited. We see that in this case there is no public exposure, because why? We shielded this system from the outside, right? So we didn't really want to reach anybody from the outside. And then when you go down here, you see the actual attack path, right? You see that's my internal IP. I tried to break into the system from this entry point. I see an SQL injection attempt with a certain database. So what happened here is we see the entry point, you see my payload, and you see how we realize that this payload ends up in this statement here. And we also see that this is the actual statement that was tried to be executed. And we also know which element of that was the input that I controlled, which is the injection attempt. So that's kind of powerful, because it allows us to block all kinds of SQL injection attempts independent of the pattern here, right? Because the magic lies in the actual analysis of where did the data come from and what did it cause ultimately. So if you would enter the same data, this same attack string, and you would not reach an SQL statement with it, we would not alert you, right? And that's quite of a difference to, let's say, a web application firewall, which would simply react on patterns, no matter if they would cause any harm. So before I open it for questions again, let me just show you one other example here. And of course, it's demo time, so it's loading slowly. So I shouldn't have hit reload. The other example I want to show you is the JNDI injection attempt. And come on, build up. When you look at the JNDI injection attempt, you can also see we're tracking basically the same thing. It's just a different destination where this ends up, right? So you see here this kind of install backdoor item. Actually, I'm looking at an old element there, I think. I'm sorry. Yeah, let me explain further, and I'll need to quickly figure out why we have a delay there. But just to finish the explanation, so you see where the input came in. You see also where which function was hit, and you also see what arrived at the very end, right? So, and that's kind of cool, because it doesn't really matter how much obfuscated the string here was, because ultimately you will always see the clear plain text, in a sense, of what was really tried to be done by the attacker. So, and with that, I think I'm already deep into the tech stuff. I'm sure there are questions.
It's just fascinating. Every time I look at it, and you can also see that people are asking questions. So the first actually came in, when did the attack detection make it into the product? I think it was a couple of weeks ago, I mean, or actually months. Maybe you can just comment on it when this feature came in, because some people may have never seen it.
No, it's actually brand new. It came in with June, and currently what we are doing is we're enabling it in selected environments and guide customers through it. Not so much for technical reasons, but we want to enable people to do it right and use the feature to the full potential. But it's available generally now.
Okay, perfect. And Howard is saying that's a big benefit. I think the initial announcement about this capability was already, and I sent a blog post as part of the answer, was already back in February when we announced it that we're working on it. But so you just confirmed general availability was in June. Another thing that came in, once an attack or vulnerability is remediated, will Davis automatically block the attack in the future if attempted again? Would this require any tools like ServiceNow or Ansible?
So if the same attack is found, and I mean, maybe it's actually, I wanted to do that anyhow. Let's skip ahead here. So there is a way to block, of course, here. So I showed you so far only the detection capabilities, and independent of ServiceNow and Ansible, you can do that basically inside of the product. You can let's move there quickly. So you can switch the whole thing to blocking mode. You can do that either specifically for individual attacks or attack types or locations. But now I'll just enable it globally, right? So you can enable here the blocking mode. And as soon as
I think you're currently not sharing that screen.
Oh, I'm sorry. I forgot to. I forgot to resume. Sorry. So sorry for that. In the end, I just navigated to the settings, right? So just to show the setting as it was before, there was monitor mode, right? And I just changed that to blocking mode, right? And from now on, Dynatrace takes care of blocking that inside of the product. So there is no need to have any kind of Ansible or whatever outside of the product. You can switch the agent to basically say, if that happens again, block it immediately, and then simply the attack will fail. Does that? I hope that answers the question.
I think so. I mean, I guess that's what it is. Robin, if you have any additional questions, I think the point is that you can block the calls by default, which means I assume technically what do? We throw an exception in that code if it's Java, or we just return, or what's the technicality on this?
Yes, so what we're currently doing is we're interrupting basically the session in the most sensible way that would not kill the application. So that means we are throwing an application and that means we're not killing the application just because we blocked that one thing. The downside of that is obviously that depending on how the application or how the exception is handled, you would either say an error, a sensible error, or not a sensible error. But that's application specifics, right? So that depends on how the application is built. Mm-hmm. The whole idea is that we want to interfere with as little with the standard application flow as possible. So we'll not just stop there and do nothing anymore. But if there is a way that the application is built that an exception is thrown and something is going wrong, and this is then handled by showing an error to the user, then of course we will leverage that.
Yeah. There's one other question. How do we activate this feature? You said you're working in conjunction with the customers. How can they get it into the environment? I think the best way, if you want to have AppSec, is probably reach out to your Dynatrace account team or your Dynatrace One team. So you can probably also just use the chat feature in Dynatrace and say, hey, you have seen AppSec in a webinar that we did, and you would like to try this out. So Daniel, and also everybody else who is interested, just reach out to your Dynatrace account team or just through the chat, the in-product chat, and then this can be enabled. And the other question that just came also from Howard as a follow-up, will it be in the cloud, AWS? I'm not 100% sure, Howard. If you can maybe rephrase that question, because I'm not 100% understand the context. this feature that Andreas is showing, right? This works for both our Dynatrace SaaS and managed offering, I would assume.
Yes.
Right?
So it's working independently of where you deploy Dynatrace, but maybe the other option to interpret the question is it's also independent of where you deploy your application. It works wherever your application is running, either in AWS or Azure or on-prem. We don't care. As long as the agent is there, the feature works.
Yeah, exactly. And he's asking, will it be going hybrid cloud? Dynatrace itself is hybrid cloud, right? We are monitoring and observing and tracing your applications in hybrid cloud environments, and all of the data that we have will automatically then also be used for AppSec. Yeah.
Yes.
Cool. Sorry, one more question. I know we need to also keep an eye on the time, but can you show again how AppSec differentiates from a WAF during attacks, a web application framework, I guess?
Absolutely. So let me show that maybe with the example, or let me find a better example that has that. So while this is loading, in general, when you think of a WAF, the WAF is deployed at the perimeter of an environment, right? So it's the whole promise of a WAF is you deploy it once and then it's protecting the entire environment. But when you think about it, the WAF doesn't really know what it is protecting, right? It needs to be fed with lots of rules that help the WAF to understand what needs to be blocked how, right? So that means a WAF cannot, and that's my first element, a WAF needs to have an up-to-date rule set or have some kind of advanced learning mechanism, but it needs to understand what is currently there, and that needs to be very accurate, and ideally it's tailored to the application. So ideally, somebody would tweak the WAF settings as soon as the application changes behind, because that if I had no SQL vulnerability or database deployed so far, then as soon as I deploy one, I maybe want the entire SQL injection rule set, right? So there's this kind of dependency between what is protected and what the WAF is using as patterns. And then there's the second element, and I'm now coming back to this part here. So imagine when Log4Shell hit, what attackers did is they came up with a lot of very obfuscated patterns like this one here. So I'll show you quickly. So that thing here is exactly the same string that does exactly the same that I showed you, but it's just very, very heavily obfuscated, right? And the reason why this worked for attackers is because the WAF is sitting basically on the network, or I mean on the application layer on the network, but still it's sitting on the network, and it doesn't really know what's the outcome of de-obfuscating this string. Dynatrace knows that because we see the obfuscated string coming here, and we see what is really built out of it, right? So what we will see is always this string, because it's just the result of the de-obfuscation that is happening as a mandatory step of the application logic. Otherwise, even the exploit wouldn't work. So that's really the two core parts. I know that's a kind of a tricky topic, and I hope I explained well enough.
I think you did, at least the way I understand it, right? I mean, keeping all of the different permutations just takes would take a lot of effort to then define all of your rules in the front. I'm sure there's obviously regular expressions that you can use and stuff like this, but really knowing what ends up in the back end is the thing that really matters.
Exactly.
And Max was just saying, yes, thank you. Hey, another question just came in, follow up from earlier, just a confirmation. Just to be clear, this functionality is now fully available and isn't early adopter functionality, and they are running Dynatrace managed. Will it affect tenants on the cluster, or can it be activated per tenant? I guess the tenant, they mean in Dynatrace environments on managed. I think how the enablement of AppSec can be fully controlled on which areas, right, you want to enable AppSec.
Yeah, exactly. And that's exactly what we typically do. I'll tackle the second one first. So you can control in a quite fine granular way where you want that. So what we typically do is that we enable it in pre-prod first, to allow customers also to evaluate and understand whether they trust us enough, to be frank here, to make sure that they want to have that in production ultimately. So that's possible, obviously. And then to the second, or actually first question, Yes, it is. It is available, but as I said, we're currently doing like a staggered enablement together with the sales team, because simply we want to have good guidance of all customers and not just turn it on in a big bang everywhere, but make sure that that's pretty powerful. We want customers to understand what they get there and attend them while this is enabled.
Mm-hmm. And then as a follow-up question, just I think a clarifying question. So this works on code level. That means you can really detect if a vulnerable function is called, and like we can see it actually here, because the vulnerable function is the lookup function. And we even have the parameter, the JNDI lookup name. That means our detection works on truly dynamic code instrumentation, where we can see not only that maybe a library is loaded, but that the vulnerable function gets called, and if it gets called, you even have the information about whether the vulnerability was exposed, because you can see exactly the data, the exploit that was put in. Yeah.
Yes, I have nothing to add.
Yeah. Absolutely
correct.
Yeah.
Maybe one element here, maybe that's also helpful. We can also reverse that, right? So this was the attack, right? But you can also see the vulnerability here. And you can basically have the inverse view on this situation. You see here, there is lots of context. Again, I said I will say context a lot of times. We care about context to allow people to understand what's going on. You can see then in this case, we had already 3,700 something attacks on that, on this vulnerability. But again, here you can track it, right? So as soon as it's gone, and I didn't explicitly say that previously, as soon as this is gone, we will mark that as resolved, right? So we understand whether it's still there, because we always understand what your current deployment looks like. So you would then also, and you can see that here, you were tracking the state of this problem, right? So at some point it was resolved because we undeployed the vulnerable code, and then it was reopened because we had 3 affected processes with the same thing. So we allow you to track that over time as it appears and disappears. Mm-hmm. Any questions before I come to my final part?
Just if .NET is supported, and I just posted the link to a blog post that was already from last year. I know you also have some what's coming up, but yeah.
So yeah, maybe it's hinting already at what's coming up, but currently we support Java with attack protection, and we support Java, Node, .NET, and PHP for the vulnerability and risk assessment. And of course, the idea is to have like parity with the supported technologies over time. The next one we are tackling for attack protection is .NET. Yeah, let me just show you. I mean, I thought it would be also useful to zoom out at the very end, to make you see that I don't want to talk only about attack protection, while it's seriously cool and about vulnerabilities and risk assessment. But in the end, what many customers want is an overview of what's currently going on in their environment outside of these kind of emergency situations, right? So I just want to hint at that real quick, what you can do there, right? So you can, of course, being an observability platform, we have all kind of metrics that you can monitor. So in this case, I'm using here the one for open security problems, and let's say I want to split them by risk level, and let's say I want to filter by type and only care for third-party vulnerabilities. So I can query this metric. I will get now here a chart over time. I can, of course, extend the chart to a certain time frame. So that's 7 days. And also I can do like a different visualization. What do we pick? Let's take an area chart, for example. So let's say this is what I want, right? So this is what I need for my daily life. I want to look at how I'm doing overall as a starting point. And then I can, of course, pin to a dashboard, right? So if you do that here, then I can open the dashboard here, and then you would see the very same dashboard tile, or the very same chart as a dashboard tile. And of course, you can combine that with all the other information we have. So I'm just trying to say, we are not trying to build an isolated solution for security here. It's meant to be integrated with your observability needs. And if you need a performance chart next to it, that's absolutely supported.
And maybe to this point, because this is what I love about it, because I work a lot with the DevOps community, right? The having metrics available about newly detected vulnerabilities in a certain environment allows you to use this as part of your release validation. If a new build coming through your pipeline and Dynatrace monitors that environment, you can say, I'm not letting a build pass that has a detected vulnerability in Dynatrace. Let's say you run your automated performance tests or functional tests, and then as part of the quality gate, or we call it release validation, you can say, besides performance, besides scalability, I also don't want to let a build pass if there is a new critical vulnerability introduced.
Right.
And then one more question just came in. Any hooks from an incident management perspective? That means, is it possible to trigger external tools in case a vulnerability, a new one, is detected?
Yes, so far we connected. Of course, the very first thing we did is APIs. So maybe I say that just as for completeness, everything you see there is also accessible via APIs. So our internal teams used it quite a lot in order to build their custom integrations. Second thing, of course, we added is webhook integration. So whenever there's a new vulnerability appearing or a new attack being detected, you can trigger a webhook. And there's also Jira integration. And another thing we'll add, I think next month is email integrations, because that was also a common request. And of course, we will go on adding more integration options there.
Mm-hmm. So it's not the same integrations we have right now for general problem alerts. So we are providing a couple of integrations.
Yeah, it's a subset of those. Mm-hmm. It's a subset of what is already there.
Yeah.
Yeah, maybe with that, if I jump back to my deck. So next things to come. Very briefly, I said that already, we want to support more tech. So I want to be clear here. When I showed the full stack vision there, obviously we don't cover everything there. We do cover, for example, vulnerabilities in Kubernetes itself. We obviously cover a lot of different technologies for library vulnerabilities. We're also extending in the direction of supporting vulnerabilities in language runtimes, like the JVM, for example. And then, of course, there's many other gaps we need to fill, but the big idea is we want to cover as much of the stack as possible. And of course, we're looking for customer input there. And the second element is, of course, attack protection. And there, as I said, Java, .NET, and then we'll see what's next. Then we realized that, I mean, many customers find lots of what we're doing really useful, but we also have received requests for more metrics. I mean, can I have this particular metrics sliced per management zone as a list? So very specific things. And we realized that for daily operations, we need to also extend our metrics and dashboarding to allow for this kind of continuous reporting use cases more. So that's also coming. And then the last thing is more tech types. So far we support SQL injection, command injection, and this Log4Shell GNDI injection family of things. And by that, I mean the entire family, right? So I'm not saying a particular pattern or a set of pattern, but we support the family of attacks. Of course, we will extend further to also other families of attacks, like there's, for example, SSRF is a very common attack pattern that we're currently looking into. Mm-hmm. And if you want to learn more, I just linked to the docs here, that there is a lot of information there. It's also continuously updated. And there's also perform videos from last year that we can absolutely add to this link list. It just came to my mind. Yeah, with that, thanks to everyone for listening. And I'll just see if there's any final questions or any comments from you, Andy.
There's one final question that I haven't yet answered. It's about being more granular over and having more control on which kind of environment is getting AppSec enabled, whether there's a plan to do this via tagging, via management zones, or what's possible right now.
So what's possible right now is you need to differentiate there a bit between vulnerability detection and attack protection. So for vulnerability detection, we support selecting individual hosts, or we also, the inverse always also works. You can also ignore a particular host and enable it to all others. The same is also true for processes, and also tags are supported. So we're looking for tags on processes and hosts. For tag protection, we're a bit behind. We're extending there further. We currently support only hosts there. So you need to tell us which host you want to enable it for, and then you can do that.
And from a notification perspective, I think this is also what the question was hinting to. Can you then send notifications depending on where the vulnerability was detected? Is this planned as well?
So currently it's not. That's so currently you can only do that basically globally. And frankly, we discussed it quite a lot of times. And in the end, the best solution was for us ultimately always to build it on top of webhooks and some custom logic, or on top of APIs, because we found that the customer needs are there so different typically that it's hard to fit that really into the product and do what customers need there. And our internal teams are doing it the same way. So happy to discuss that further if anybody wants to just get in touch, but that's our current position there.
Yeah. All right. Hey, I'm sure there will be more questions from the audience. Please follow up with us later on, because I promised Andy that he is managing to get to his next meeting, which is very important. And Andy, awesome. Thank you so much for this. This is truly exciting. And I know there's so much more to come, but we're making security not everybody's problem, but we're actually making security everybody's option to actually build and deploy better secure code, because we're baking security into your life cycle. And I think with this, I really like the whole idea of being able to focus better on things that really matter, because we cannot solve and tackle every problem that is detected. We need to focus on those that really matter. And I think that's what we're doing pretty well. So
thanks, Andy. It was a pleasure as always. And thanks everyone for listening in.
Thank you. Bye-bye.
Thank you.